Hello, welcome, and now we're going to talk about de Moivre's theorem. Now, de Moivre's theorem we've covered in a previous video, but we're going to review it for this chapter because it's important. So, de Moivre's theorem says if I have a complex number in polar form, and I'm going to take a power, positive power, so n is a positive integer here, then all I have to do is apply this formula. I'm going to take the nth power of r and the multiple, right? I'm going to multiply the argument by n. Okay, that's it. Now we've seen this before, but it bears repeating. So let's do an example just to refresh your memory. And let's take, I have the 1 plus I to the 5th power. Oh, by the way, if you this just comes from repeated use of the product rule that we went over in the previous video. Okay, so all we're doing, that's where de Moivre's theorem comes from, is the fact that we can keep repeating this over, because, let me slow down. We can keep repeating the product rule for complex numbers, because remember, powers are just repeated multiplication. So you can see where this comes from. So let's do an example. Okay, so I've got 1 plus I to the 5th power. And so now what I'm going to do is I've got to get it into polar form. So to use de Moivre's theorem, I have to first put this in polar form. So I've got y, so x is 1 and y is 1. Okay, so the first thing I'm going to do is find r. So r is going to be the square root of y squared plus, or excuse me, x squared plus y squared. And so this is going to give me the square root of 2, right? So there's r. Now, to find the argument, I need to find theta. To find the argument, which is theta, to find the argument, I'm going to use tangent, okay? Because all I have is x and y. So the only trigonometric function that I can use is going to be the one that gives me the ratio of y to x, which is tangent. So I know tangent of theta is 1. Well, the only angle, and by the way, this is in the first quadrant, by the way, as you can see. And so the only angle in the first quadrant that gives us a positive 1 is pi over 4. 45-degree angle, right? Because 1 over 1, right? So the only ratio that gives us 1 over 1 is a 45-90 triangle or a 45-degree angle. So now we've got this. So now we can rewrite this in polar form. So this is going to be r's square root of 2. So it's going to be the square root of 2, right? But it's going to be the square root of 2 to the 5th power. Okay? Now, and then we're just going to multiply theta, which is pi over 4, by 5. So it's going to be cosine of 5 times pi over 4. So it's going to be 5 pi over 4 plus I sine 5 pi over 4. Now, 5 pi over 4 gives us into the 3rd quadrant. Okay? So now that we've used de Moivre's theorem to get to this part, now, oops, hold on a second. That's to the 5th, not the 2nd. Okay, so now what do? Well, now we can start simplifying this, right? So this is going to be 4 root 2. How do I get that? Well, remember, we can write this as 2 to the 5/2 power, right? And so we can split this up as 2 squared times, well, let's write it this way. This is going to be two over 2 plus 2 over 2 plus 1 over 2, right? So I just rewrote the exponent like this. And so that's going to be 2 times 2 times square root of 2. And that's what I get here. Okay, so now, what do I end up inside? Well, cosine, now this is, again, 45-degree angles in the third quadrant. Cosine is negative in the third quadrant. So is sine. Remember, this sine and cosine are both negative. Okay, so this is going to give us what? It's going to give us negative square root of 2 over 2, right? And this is going to be minus I, well, let's put I in the back because we're dealing with the numbers. So this will be square root of 2 over 2I, okay? And then I'm going to distribute the R, the modulus, okay? And so what do I get? I get, well actually this is going to be, the 4 is going to divide by 2, so that's going to give me 2. It's going to be negative 2. And then this times this is just going to give me 2 minus the same thing. And I'm going to get, okay. And what do I get? I get negative 4 minus 4I. And that's my final answer. Have a great day.